Dear students, in the previous video we have learnt about 8255, its block diagram and what are all the pin details of 8255. In this video we will try to understand the modes of operation of 8255. So in this modes of operation the most important thing what you have to learn is the control word register. So you know that when your A1 and A0 is operated at 1 1, you will have the control logic. Your control register will be selected. So this is my control word register which says what my each and every port is going to do. This control word register consists of totally 8 bits, 8 bits D0 to D7, and each and every bit has its own value. When I take D0 here, this D0, in this D0 you will have port C, lower will be selected. If you put D0 to be 1, port C lower will be acting as input. When you put D0 to be 0, port C lower will be acting as output. Similarly for D1, it is port B. When it is taken as 1, entered as 1, port B will be acting as input. When it is entered as 0, port B will be acting as output. Next one is D2. It is the mode selection for this group B. So D0, D1 and D2 will be decided, or this will act on group B. So mode selection, when you enter 0, mode 0 will be selected. When you enter 1, mode 1 will be selected. Similarly, the rest of the pins D3, D4, D5 and D6, it is used for group A. For D3 when you take, it decides your port C upper. When I enter as 1, port C upper will be acting as input. When I enter as 0, port C upper will be acting as output. Similarly, your D4 when you take, port A will be acted upon. So when port A, here when I enter as 1, port A will be acting as input. When I enter as 0, port A will be acting as output. Here I have got two mode selection pins, D5 and D6. When D5 and D6 are entered as 0, 0, mode 0 for group A will be selected. When it is entered as 0, 1, mode 1 for group A will be selected. When it is entered as 1x, maybe 1, 0 or 1, 1, mode 2 for group A will be selected. The last pin D7. D7 will be, this control word register will be active, or it will be acting on different modes when this D7 is put to 1. Okay, so this is my control word register. So when you take your modes of operation of your 8255, there are two important modes of operation. The first one is bit set and reset mode. That is bit, which means that this bit set and reset mode is operated only in port C, and it is a bitwise operation. When I am going to send data bit by bit, then we go for this bit set and reset mode. The other modes are input output modes. So here you will have three modes available: mode 0, mode 1 and mode 2. Mode 0 means simple input output. Mode 1 is handshaking mode. Mode 2 is bidirectional data transfer. So we have learnt about the control word register already. Here for this mode selection, if I am going to act in mode 0, I have to put 0, 0. Mode 1 means 0, 1. Mode 2 means 1, 0 or 1, 1. So that if I put 0, 0 means you can see that which mode will be selected. Mode 0 will be selected, which is simple input output. If I put 0, 1, mode 1 will be selected, which is handshaking mode. We will be learning what is handshaking. If I put 1, 1 or 1, 0, you will have mode 2 will be selected. Okay. So these are the modes of operation of your 8255. So here we will see first what is this bit set and reset mode. I said this is a bitwise operation, and here only port C will be activated. Your port A and port B does not come into role. So the same control word register for bit set operation will be taken over like this. So for bit set operation, remember your D7 will be set to 0. So see here, your D7 will be set to 0 for BSR or mode. And your D4, D5 and D6 does not take its role. It will be a don't care condition. You don't need to put anything. You can put either a 0 or a 1. It is a don't care condition. And here the D1, D2 and D3 are the bits which sets my port C bit. So D1, D2 and D3 will be setting my port C. And here set and reset pin will set whether it to 1 or to 0. Let me show you what actually happens over here. So here when you take, see here. So B1, B2 and B3, when all the three inputs are 0, 0, 0, your PC naught will be set. When it will be set in the sense, when this set bar reset is set to 1. When this is equal to 1, when this is equal to 1 means here it is 0, 0, 0. Then what will happen? Your PC naught will be set. When it is 0, 0, 1 and this is equal to 1, then PC1 will be set. When set bar reset is made to 0, then this input will be reset. Okay, so this is how the selection of different bits, bit by bit operation, PC0 will be operated separately, PC1 will be operated separately, PC2, everything will be operated separately depending upon the bitwise value. What do I give here over to this B1, B2 and B3. And here each and every bit can be controlled only in your port C. Your port B and port A cannot do all these operations. Yes, so this is bit set reset mode. The second mode of operation is your input output mode. So here in my ports, here rest of the ports are going to act in your input and output. So data transfer is going to happen in a bulk, in a set, by this input output mode. When I take my mode 0, which is the simplest form of your operation, mode 0, it is simple input output. So both your A and B ports are used as simple input output ports, and your port C 4 bits will be used for input output operation. Okay. So here simply directly you can send data, directly you can receive data with the help of this in this mode through this and it is very simple. So here the features of this is outputs are latched. What do you mean by latching is that your outputs can be stored for temporarily and it can be sent. So that is called as latching. But inputs are not latched, immediately the transfer should happen and you do not have any handshaking. Handshaking in the sense no interrupting will be available in case of your input output mode. Very simple mode. The next mode is your mode 1. Mode 1 is your handshaking mode, your input output with handshaking. So what do you mean by handshaking is that I will be interrupting my microprocessor with the help of this handshaking signals. So that is called as handshaking. So here your port A and port B will be used as simple input output ports. Along with this, your port C3 lines will be taken for handshaking. Handshaking or interrupting signals, that is going to interrupt my microprocessor. Okay, so here both your input and output both are latched, which means that I can store my input temporarily, I can store my output temporarily for certain period of time. So here interrupt logic is also supported. I can interrupt the microprocessor and I can do the data transfer. So that is available with the help of this handshaking signal. So let me see what is this handshaking signal. So handshaking is an input output control method which is used to synchronize your input output device with the microprocessor. So both will be operating at different time periods. To synchronize, we go for handshaking. Because my input output device may be acting slow, my microprocessor is fast. So in that case, what should I do? I have to make my input output device to work along with the microprocessor. For that, I go for this handshaking. So for handshaking, you have got a strobe pin, STB. So what happens in the strobe pin is that the peripheral device from which I am going to send the data, once data is transferred, this peripheral device will generate your strobe pin. Okay, so your input output device will be connected to your 8255. 8255 will be here, you will have your 8255 and here input output device. So once this input output device is communicating a data to 8255, strobe will be generated. Okay, so now once this 8255 receives the data, what it will do is it will give the input buffer full, because its buffer is has received the data. It will say that input buffer is full, which means that it acknowledges the peripheral device that it has received the data. Okay, once it has received the data, what will happen? This 8255 will interrupt the microprocessor. So that interrupt is given by means of this INTR. So INTR is the interrupt request wherein the signal will be interrupting the microprocessor. Once the microprocessor receives the interrupt signal, it will read the data. Once the data is read, the microprocessor will reset So interrupt request will be sent by the microprocessor. Once the microprocessor, here is my microprocessor, once the microprocessor reads the data, it will send the interrupt signal. It will acknowledge the interrupt, it will read the data, then immediately it reads the data, microprocessor will reset the data. Okay. So now how all these are going to work is with the help of this interrupt enable. So interrupt enable, when this pin is equal to 1, then only INTR will be set. When interrupt enable pin is not equal to 1, then INTR will not be set. Yes. So these pins, your strobe, your IBF, INTR will be the pins of your port C. As said earlier, we have seen already that when you take your port C, in your port C, few signals will be used for handshaking. 3 signals. These 3 are the signals which are used for handshaking. Strobe, IBF and INTR. These are the 3 signals which are used for handshaking. When all these, when there is a data transfer, then all these will be activated. Yes. The next one is your mode 2, which is bidirectional data transfer. Bidirectional data transfer is more or less similar to that of your mode 1. Here it is used for communication between 2 computers. In that case, I go for bidirectional data transfer. It is not between an input-output device. It will be probably between 2 computers. In that case, we go for this mode 2. So here, port A is configured as the bidirectional port. Port B will be operated in mode 0 or mode 1. And port A uses 5 signals from port C. For here again, handshaking plays a role, and 5 signals from port C will be taken for handshaking for data transfer. The remaining 3 signals will be used as an input-output port. Yes. So these are the modes of operation of your 8255. Totally 3 modes are available: mode 0, mode 1 and mode 2. Mode 0 is very simple, no handshaking is available. Mode 1 you will have handshaking for data transfer, and mode 2 also it is a bidirectional data transfer with handshaking. Handshaking is producing an interrupt to the microprocessor to accept the data or to send the data. Yes. So now this is one example. Let me show you. Find the control word. If suppose port A is output with handshaking, port B is input with handshaking, port C is an output, port C lower is an output, port C upper is an input. So what will be the control word should I put over here? So here I am going for input-output data transfer. So for input-output data transfer, you know that the 7th bit should be set to 1. It is not BSR, it is input-output data transfer. So 7th bit which should be set to 1. So now your port A is taken as output with handshaking. Handshaking means it's mode 1 operation. So here D6 and D5 should be set to 0, 1. Okay, so 0, 1 will be selected. You can see here 0, 1 is put over for D6 and D7. Then here comes your D4. D4 is your port A operation. Port A is an output operation. So since it is an output, this D4 will be set to 0. Okay. Then comes your D3. D3 is your input-output function of PC upper. For your PC upper, it is an input. Since it's an input, it will be set to 1. For D2, D2 is your mode operation for port B. It is mode 0 means it is 0. Mode 1 means it is 1. Since it is mode 1, here 1 will be set. Okay. So then D1, when you take, D1 is for port B. Port B is taken to be input. So since it is an input, 1 will be set over here. Then finally your port C lower. Port C lower is taken to be your output. Since it is an output, this will be put to 0. So finally if you take, see what happens. 1010 is A and 1110 is E. So this is my control word for this operation. When I put this control word, this operation will be taken into account. Yes. Similarly, another one example I am showing you. You just go through this. Port A output, port B output, port C output, and port C upper is output and port C lower is also output. So you will have ADH. Another one example. Work it out and see. Port A is input, port B is input, port C upper is input, port C lower is input. So depending upon what port I am going to use, what operation I am going to do, to set my control word so that the required operation will be done by my 8255. So with this, we are completing the parallel communication interface 8255. Thank you.